We are going to discuss a JEE Advanced 2025 paper 1 question 3 solution. This some faculties are saying that this is a controversial question, but according to me this question is not a controversial. It has an accurate answer, which is option C is the correct. B option cannot be the correct option. So according to me there is no controversy, and the accurate solution we are going to see. So the question is, let R be the set of all real numbers and defining function f from R to R. F of x is 2 minus 2x square minus x square sine of 1 by x if x is not equal to 0, and 2 when x is equal to 0. So the question was, which of the following statements is true? So first option is the function f is not differentiable at x equal to 0. So we are going to check this option, and this option is incorrect according to me, and please be aware of that. There is no controversy on this question. The accurate solution we are going to discuss. So computing LHD at x equal to 0, f of 0 minus h minus f0 by minus h limit h tends to 0. This is a definition of left hand derivative. So limit h tends to 0, putting minus h instead of x in this function, and I get the value 2 minus 2h square minus h square sine of minus 1 by h, and f0 is minus 2 by minus h. So this 2 cancel out, this minus h cancel 1h from these factors, so 2h minus h sine of 1 by h. Because of this minus, there is come minus h of a sine 1 by h, and this limit is going to 0 when h is going to 0. So LHD at x equal to 0 is 0. Now computing RHD at x equal to 0, f of 0 plus h minus f0 by h, this is equal to the limit h tends to 0, putting h instead of x in the given function, 2 minus 2h square minus h square sine of 1 by h minus 2 by h. So these 2 cancel out, and h is cancelled out from these common factors. So limit h tends to 0 minus 2h minus of h sine 1 by h. So putting h equal to 0 in this expression, I will get the limit is 0. So at x equal to 0, derivative of function is 0. So my f dash x is minus 4x minus 2x sine of 1 by x plus cos of 1 by x at x not equal to 0, and at x equal to 0 the derivative is 0. This derivative is follows from the differentiate of this function, because the differentiation of the function is splits over addition and subtraction, and here we use product rule for the differentiation. Now according to me the next option is also incorrect. The next option was, there is a positive real number delta such that f is decreasing function on the interval delta comma 0. So if you take the right neighborhood of 0, and you have to show that it is not a decreasing function, that is the derivative of function is not equal to 0 in any neighborhood of any right neighborhood of 0. So according to me, for any delta greater than 0, I can choose n naught belongs to natural number such that 1 upon 2 n naught pi is inside this interval. By taking large natural number, I can make this quantity to be inside this right neighborhood of 0, taking n to be the large natural number. So this quantity become very small, and this can become inside this interval. So at this point the derivative of f is minus 2 n naught upon pi minus 0 plus 1, because sine at any multiple of pi is 0 and cos at any even multiple of pi is positive 1. So this is minus 1 minus 2 upon n naught pi, which is always positive because this quantity is less than 1. So this is positive. So I get a point inside this interval such that the function the derivative of function is positive. So function is not decreasing in this interval for any delta greater than 0. So B option, which some faculties are saying that it can be correct, but according to me it cannot be the correct. So taking C option, for the C option was, for any real positive number delta, the function is not increasing its functions on the interval minus delta comma 0. So if I take left neighborhood of 0, so for any delta greater than 0, we can choose n naught such that minus 1 upon 2 n naught plus 1 pi is inside that interval. So the calculating the derivative of f at minus 1 upon 2 n naught plus 1 pi, so I get 4 upon 2 n naught plus 1 pi, and at any pi multiple sign is 0, and cos at odd multiple of pi is minus 1. So the expression is minus 1 plus 4 upon 2 n naught plus 1 pi, which is negative because this quantity is always less than 1. So f, we get a point where the derivative of function inside this interval is negative. So function is not increasing in minus delta comma 0 for any delta greater than 0. Now coming to the last option. The last option was x equal to 0 is the point of local minima of x. So this option is also incorrect. Suppose x is a point of local minima of f. So f dash is 0 for all x in the left neighborhood of 0, because 0 is a point of local minima. So left neighborhood is decreasing and right neighborhood is increasing. So f dash must be negative in the left neighborhood of 0 for some delta. But if you compute f dash of minus 1 upon 2 n naught pi, this will be the 2 upon n naught pi plus 0, and even multiple of this is cos, we get 1. So this is the positive quantity. So any neighborhood, any left neighborhood of 0, I get a derivative of function is positive, which is a contradiction to the statement that it has a local minima at x equal to 0. So hence x equal to 0 is not a point of a local minimum of f. So D option is incorrect. So this is my solution to this problem, and according to me the option C is an accurate option for this, and B cannot be the correct option. I have shown in my solution, and thank you for your concentration.